This is Jan 2009 M1, question number 6A. Okay, so we have two forces. It acts on a particle, it has mass m. The resultant of the two forces is r, and it is given that this is parallel to this vector. So find the angle between r and this. So parallel means the direction vector is the same. So if this is I axis and this is j axis, this is the origin. So since they are parallel, the angle would be the same. So I minus 2j. So this is I, so 1 minus 2j is this negative. So this would be the vector. So if this is the vector, we need the angle with the j vector. So this is the angle that we need. So this is 90 degree and this is the angle that we need. So let's draw a miniature triangle here. So this length here is going to be 2 because length cannot be negative, and this length is 1. So theta, we can use tan theta equals to opposite by adjacent. Therefore tan inverse of half is going to be, it's not, opposite is 2, so this should be 2 by 1. 2 by 1. Okay, tan inverse of 2 by 1 is 63.4 degree. So answer, the angle with j is, so this is 90 degree and this is 63.4. that makes it 153.4 degree. Question number B. Question number B, before finding this relationship, we know one thing, that the two forces together make the resultant force. For that reason, what we have is this resultant force equals to F1 plus F2. So it is going to be 4i minus 5j plus pi plus qj. If we add it up, then that would be 4i plus pi is going to be 4 plus pi plus minus 5 plus qj is minus 5 plus qj. We also know that this resultant vector is parallel to this vector I minus 2j. So if they are parallel to that I minus 2j, so this vector is also some length of I minus 2j, because if something is parallel, they have the same direction, but we don't know how long they are. What is the length of that line? They are like this. One is this, the other is this. They're going in the same direction, but we don't know how long they are, so we're just making it up. Suppose in order to make this equal to r, we have to multiply by some lambda. So lambda I minus 2 lambda j. So if we equate the two, so what happens? One of the r is for I equals to I, we will get 4 plus p equals to lambda, and for j equals to j, we'll get minus 5 plus q equals to minus 2 lambda. So if we call this equation 1 and if we call this equation 2, hence now if you plug in this lambda here, it would be minus 5 plus q equals to minus 2. Lambda is going to be 4 plus p, so this is going to be minus 5 plus q equals to minus 8 minus 2p. Let's bring this minus 2p on this side, it would be plus q, and this would be 8 minus 5 plus 3 equals to 0. Done. The expression has been shown. In question number C, what we know is q equals to 1. So when q equals to 1, we can plug it in here. So 2p plus 1 plus 3 equals to 0. Therefore 2p equals to minus 4. Therefore p equals to minus 2. So you do not need to do this in order to do question number C. You can just plug in the value of q and find this, because this is 7 mark after all. So we know the value of p, so therefore r equals to, so as we know, expression for r is 4 plus p, so it would be 4 minus 2i plus minus 5 plus q, q is 1, plus 1j. So this would be 2I minus 1 minus 5 is minus 4j. So we know the resultant force. Since force equals to mass into acceleration, and we can consider this to be the modulus, so this would be 2 squared plus minus 4 squared, that would be 4 plus 16 square root of 20. So this would be, the force would be square root of 20 equals to mass, and the acceleration is given. So the acceleration is 8 root 5. So 8 square root 5. Therefore m equals to square root of 20, which is 4 5s are 20, 2 root 5 divided by 8 root 5. This root 5 and root 5 cancels, 1 by 4. Therefore m equals to 1 by 4.